let's dive right into some core operational terminology. Specifically, we're looking at modes of steering today, focusing on Azimuth, cruise mode, and fast steering. Now, steering a massive modern vessel is definitely not just about turning a wheel. There are three little words on a bridge control panel that completely change how your Azipod behaves: Aziman, cruise, and fast steering. And honestly, mixing these up during complex alongside maneuvering is a genuine safety risk. We're talking catastrophic damage to the vessel, the berth, or nearby tugs. You absolutely have to know exactly what the system is going to do before you even think about pressing that button. But before we even touch those bridge controls, let's take a quick physical trip right to the stern of the ship. Down here is your ultimate fail-safe, the Azipod room. This aft compartment houses the whole operation: the steering gear, hydraulic power units, and monitoring cubicles. If the bridge ever suffers a massive failure, this room right here becomes your primary emergency control location for both propeller RPM and steering. It's basically your absolute baseline of safety. Okay, so once you're back at the controls, you're looking at a fundamental mechanical trade-off. First up, we've got Aziman mode. This combines propulsion and steering, letting the pod rotate a full 360 degrees for infinite maneuverability. But because you're using this right near the berth, the propeller power is automatically restricted. On the flip side, you have cruise mode. This is the exact opposite trade-off. You get wide open, full nominal power to cross the ocean, but your steering angle is strictly capped at plus or minus 35 degrees. Why? Because you really want to prevent dangerous roll forces at high speeds. So how does the system react under pressure? Let's do a quick active recall check. Just imagine a vessel is approaching a berth in Aziman mode. The officer at the helm decides they need a burst of speed and requests full nominal propeller power for a quick approach. Based on the trade-offs we just talked about, what actually happens when they push that throttle forward? Just take a second to think about that. Well, if you guessed the ship surges forward, think again. The system actually automatically restricts the power output, completely regardless of the officer's request. There's no override here. That restriction is a hard-coded, built-in safety feature of Aziman mode designed specifically to protect the berth, the tugs, and the ship itself from a sudden, massive power surge. It is absolutely not an operator overridable setting. The automation literally steps in to prevent human error. All right, let's quickly lock in these three essential takeaways. First, your Azipod room is that physical, aft-located emergency control center. Second, Aziman mode gives you that sweet 360 degrees of rotation for tight maneuvering, but it automatically restricts your power. And third, cruise mode opens up full nominal power for transit, but strictly limits your steering angle to plus or minus 35 degrees. Once you grasp these three things, you really grasp the baseline philosophy of the Azipod. But hey, we aren't done yet. We've established how the system trades maneuverability for power, but what happens when you actually need raw steering speed over torque against the sea? If the automation controls the power, what's the real control philosophy behind every single joystick command you issue up on the bridge? In Part 2, we're going to unpack fast steering gear mode and the critical differences between follow-up and non-follow-up control. Honestly, if your ship's automation failed right now, would you know exactly which one to use?